Hey guys, thanks for playing along with my little puzzle at the end of the last video. So what was missing from this board, as some of you correctly identified, this coil. Which makes me think that somebody undid the wires just on one side and pried the board up just so they could get that coil out. Well, I simply transplanted the one from the other board onto this board. And I finished with all the resistor and capacitor and couplet replacement. And yes, as some of you noted, the plastic tape around this coil was unraveling, so I just threw a little electrical tape around there to secure it. Probably there was some around this one at some point that's now gone. And maybe that one as well. I'll just leave them alone. The wire doesn't appear to be unraveling really, so I don't think it's much of an issue. I could always just wrap some Scotch tape around it or something. So that's basically it for this board, which leads us to the main chassis, which is in pretty nice cosmetic condition, really no corrosion. I could reinstall this board and play around with troubleshooting and replacing bad components, but I already know I've done enough of these. All the caps are going to be bad. So I'm just going to go ahead and shotgun them. So unlike the Siesta that I'm just about wrapped up with, this has a lot of components with point-to-point wiring. This must have been more labor-intensive to put together. It came out a little bit earlier than the 17-inch sets. So looking down here, I believe that's the damper tube socket. That is the socket for the yoke. And there's a socket for the pitcher tube, high voltage rectifier. Got a couple electrolytics here. There's one on the top side poking down there. So I want to replace these electrolytics. This one's in cardboard because this is a transformerless set. So it derives its B+ via a voltage doubler right off the AC line. The negative on this cap is not grounded. Don't make that mistake if you replace this cap. That would be very bad. Now, something else I wanted to note, you hear a lot of people talk about hot chassis. I'm sure I have many times in the past as well. But a lot of especially the radios I work on, it's not really true. It's actually a floating chassis. In other words, one side of the AC line is not going to the chassis. It's just all in the wiring, and the chassis is essentially floating. And I suppose perhaps one could install a 3-wire power cord and ground it, like really to earth ground. I've never actually done that. But anyways, what I'm getting at with this set is one side of this most definitely is. So here's where the AC comes in. One of these wires goes directly to this. So this is a true hot chassis. However, for safety, to minimize chance of getting shocked, the actual points where this is secured to the cabinet, even though the cabinet's wood, they isolate the hot chassis from the cabinet mounting points via these plastic bits. I believe they're nylon. So a couple screws go in here, a couple screws go in here, and that's how it's secured to the cabinet. This is floating, this is floating, this is hot. Keep that in mind if you work on one of these. Use an isolation transformer. Be careful when you're working around this. All of this stuff is potentially hot. Alright, so I got to replace this thermistor. All these paper caps are trivial to replace. This one is across the AC line. So one side is going to the chassis and one side is going directly to the AC line. Definitely want to either snip that out for while you're troubleshooting or testing it. But eventually you do want to put a safety type capacitor in there. I will replace the power resistors too, even though they might test okay. I've had enough experience with old power resistors and corrosion and stuff. I'd just as soon get rid of them. So that would be this guy, and this is the big filament dropper. Tap the resistor in here. I'll replace it with 3 discrete resistors. There's another power resistor down in here. And the electrolytics. I've done a couple holidays so far and a couple tandems. And it's been a while. I know I relocated some of them topside, and one of the projects I think I might have restuffed the cap. On some I've taken them This is only a single section cap, so I'll take a cap here and use a smaller clamp to hold it down. So I'll probably do some of that, but what I want to try doing on this one is what I've done on the Siesta, which is to find perhaps some locations on this board where I can put some of the caps. We've got 4 sections in here, 3 sections on that guy, and this AC cap. That one will definitely go top side to where the 2 rectifiers are. They're on the back side, they're over here. And I'll put the 2 caps for the voltage doubler in with these diodes. That's simple enough to do. A little less room on this one than I'm used to, though, because that's where the UHF tuner is also located. But I should be able to fit them in there. And, you know, I may or may not be able to find points on this. The Siesta and Princess boards is kind of remarkable. There are actually like some unused pads on the circuit board that correspond perfectly to where electrolytics need to go. Otherwise, it's pretty straightforward. I'm not going to bother showing you guys a video of me clipping out parts and tacking in new ones. Also wanted to briefly mention this control. This is not the original. This would be power, volume, contrast. Looks like it was built up from some kind of kit where you could snap together different decks to build up a control. But these are not locking together very well. Maybe somebody cranked down too hard on the control, I don't know. But it's kind of coming apart. But being as these replacements are really hard to come by, I just as soon try to use this. And this does not have the original action. Original action would push on, push off, whereas this is a push-pull. I do have an original one scavenged from another set. I do not know if it works. This power was a common failure point. That click action. I expect these 2 decks are fine though. But I'll try using that one. I'll see if I can secure it, sections together a little bit better. It's not often one has the luxury of having 2 nearly identical chassis you can put up on the workbench, leave one as a reference while you restore the other. This is the chassis that came with it. This is the one I'm going to use. They're actually both in quite good condition, aside from some corrosion on some tube shields and high voltage box. Both main chassis are essentially corrosion free and wiring's all in good condition, so I could easily restore either one of them. But I want to go with the UHF option, so we'll use this. Luckily I hadn't gotten very far in this one. I installed one new electrolytic up top, one down below, a couple silicon rectifiers, and I think put in one plastic film cap. So now this is just my thing, my technique. I've really primarily used it on Predictas, which is to try to relocate the electrolytics, potentially on the circuit board. Worked out great with the 17-inch sets, potentially on existing terminal strips. Sometimes there's some unused lugs, or lugs that can do double duty. So, we've got one cap here, one cap here, one cap here. You could certainly restuff these. They sell these little circuit board discs these days, made with the same lug layout as the originals, but they also have pads to install new modern electrolytics. One could remove these and install terminal strips and run the wires over to them. What I'm hoping to do is, well, the best I can with doing the minimal amount of drilling of holes or mounting terminal strips, or I certainly don't want to restuff the cans. So, where to start? Well, let's take a look at the schematic. So this is the 9L37. Let's start with the power supply. A little confusing here, they got a lot going on with the thermistor and the filament dropper and the filament string and all that. But here's where the power comes in. There's that cross the line cap we got to replace. And here's where it splits off into 2 directions. The left side is going to the tube filament string. Right side is going to the B+ voltage doubler. So that cap right there, that is the one that's in that black cardboard tube. That is on the bottom, located right there. And there's two. They use germanium rectifiers. I'll replace them with silicon. These little disc caps across them, I've been told, were to suppress transient spikes when the diodes turn on and off that could destroy these early type rectifiers. Modern silicon diodes are a bit more robust, not really needed, but I'll probably just leave them in. Then we've got two more caps and a filter choke. That's the filter choke. But where are the two rectifiers? They're up on the top of the chassis. So, move this aside for a moment. If I was to flip this around, this is the high voltage box. Imagine you flipped this over. So the filter choke is right below these two rectifiers. But this AC cap is way over here, or the one right on the AC line. And the main filter caps for the B+ are in this guy, which is over here. So part of the power supply, well, the AC comes in here, fusible resistors here, rectifiers are here, filter choke is here, one cap is here. So that's why I get to thinking they did that because they didn't have a choice. These parts are big, they had to stick them somewhere. I have the luxury of much smaller parts. I can relocate them where it makes a heck of a lot more sense. Plus they were bound, well, they got a 4-section cap. So it's going to be far away from something, because some of it's going to be used over here and there and over there. I'll be using 4 discrete caps so I can put them closer to where they're actually used. So what I've done in the past, and I started to do here, is here's 2 new rectifiers. And this little weird metal assembly thing, that is where the germanium diodes were. That whole thing could just be popped out. And a terminal strip mounted in this area, and put all 3 caps in here. That works out quite well. You got enough space. There's not a whole lot going on in that area. Now in this one there is a bit more, so it's a little more challenging because the UHF tuner's here and there's a tube on top. So you don't have that big empty space. This is where the UHF tuner would sit. But, considering how small these caps are and how big this germanium rectifier thing is that can go away, so that could potentially, we take care of 1, 2, 3, and those are 3 pretty beefy caps. And that takes care of the entire B+ power supply. Kind of nice. What about the rest? Are there any we could potentially put on the board? So how I would determine that? Everything inside this dash line is a circuit board. You won't see any electrolytics on that, of course, because they're all located off. But if we see one, like potentially this guy, 200 microfarad, 25 volt, modern caps that actually be fairly small, and it goes directly to L5U, which is one of the stakes on the circuit board, and the ground. So depending on where L5U is on this board, if there's some space around that stake and there's a grounding point nearby, I could potentially mount that cap up in here somewhere. What else we got? Let's go around the perimeter. There's another one, 20 microfarad, 300 volt, goes to stake L28 and ground. So we could find L28 on that board. If there's some area around it and there's a grounding point nearby, stick the cap right there. Keep going. Around and around. So there's one. Goes up and over. Eventually that goes to L19. That's the 140 volt bus. 100 microfarad, 200 volt. That could be relocated to the circuit board potentially. Over here, 20 microfarad, 300 volt goes to L21. That could potentially go onto the board. And I think this is the last one. That is the boost filter cap. That does not go to anything directly on the circuit board. It goes to the CRT, height control, and some point-to-point wiring stuff on the horizontal output tube and the damper or flyback circuit. So that one I do not think can go onto the circuit board. So what I want to do now is pull up those caps. I mean, physically, dig them out, see how big they are, locate those various stakes on the board, and see is there any room. Now, I'm on the 7-inch board. This one's a bit smaller, and it's a little bit more cramped. But potentially. So there's space in the middle of the board. Here's an example of what I'm talking about. This stake is L21. There should be a 20 microfarad 300 volt cap going from here to ground. Well, there's a grounding lug over in this area, and if we look underneath, we see that that lug goes to one side of this cup plate, over to one side of the ringing coil, and then over to a resistor. And then this is ground. It's a grounding stake there, and it goes up this way. So I can right away see a couple options. One is to go from here over to there, but perhaps even better would be between these two. So I mean, yeah, literally I could shove these leads down through those existing holes where those resistors are going, because one is going to ground and this one is going over to that stake. Perhaps a little crude, but certainly simple and effective, and this cap is rated for 450 volts, so really it's a 300 volt would even be smaller than this. And you could just slide right in. These holes are big enough you can easily fit 2 leads inside of them. So you don't have to drill any holes, don't have to do major modifications, just pop this guy right in, and that takes care of one of the caps. And here are some of the others. So these I can use for the power supply, and this is for the boost, and I'm still tracking down the other caps I will potentially try to put on this board. As I've been figuring out where I'm going to locate the electrolytics, I've been marking them off with a yellow highlighter. One thing that makes this a bit easier is a production run change they made early on, which this set already has, and that was to eliminate R10 and attach this cap, instead of being tied in over here through this resistor to B+, over to this point, and they eliminated C4. So this is one case where the SAM schematic is actually a bit easier to follow than the original manufacturers. What this is all about is the B+ distribution. So power supply here, here's your main power for the entire set, right here. There are 3 paths for it to go down, as shown on the schematic. It's a basic decoupling scheme, where you have a resistor and then a capacitor to ground. Makes a low-pass filter. So here's one of them. And as originally designed, this point powers the horizontal oscillator. Another path goes over here, this way, through a 1K resistor to this socket that powers the tuner. Another path, really convoluted on the schematic, goes around and around and around and around. This 275, that's the main B+. And all the way over through this 1K resistor, another decoupling electrolytic, that powers the audio output. So those are your three distribution paths right off of the B+. Well, they made a bit of a change, so they tied L21U to this point. So this capacitor both decouples the horizontal oscillator and the tuner, and that resistor is no longer there. Why is that a big deal? Why does it matter? Because R10 was located right across two lugs on this capacitor. And if I eliminate this capacitor, where the heck do I put that resistor? I'd have to add a terminal strip or figure out somewhere to put it in. This has a modification. I don't need to do it. So where is that modification? Well, this is that lug in question. So this wire goes down right through the bottom of the chassis, and this is where it connects over to that horizontal oscillator circuit through this wire. So orange wire they added goes, loops around, and ties in, I think to this point, and that is for the tuner. So I actually have a few choices. I was talking about mounting an electrolytic over here on this end of that circuit board, but it's also decoupling something way the heck over here. So I could also put the electrolytic over here. I could also put one in both places for that matter. Maybe split the difference, put a 10 microfarad on both sides, so we get the benefit of decoupling on both. There's one thing that's not so great is to have a really long run of wire between, say, the point of the power and, or sorry, where the decoupling cap is and where the circuit is. So I put the decoupling cap over here. This wire runs all around through the whole chassis and over to the circuit here. So in other words, this circuit doesn't get as much of the benefit of the decoupling cap. Put the decoupling cap over here, the circuitry way the heck over here doesn't get as much of the benefit. So actually having it here is in the middle of the two, kind of a decent place to put it. Also, if I take this cap out, I've got two wires going to that lug. I gotta do something. I could splice them together and wrap some electrical tape around it or something, or run a whole new wire going all the way from there over to here. So that's something I have to consider. And it seems like overkill, overthinking it. Partly I do it just because it interests me as an electrical engineer by education. And partly so if I build up a good strategy, if I work on more of these in the future, I'll have a battle plan ready to go. And something else to consider, where it can pay off a little to study the circuit and kind of plan where you're going to put things before you start. So there was a big 0.1 microfarad cap in here, right across the AC line, that I wanted to replace. It was going from this lug over to this lug, sitting right in here. So I dug out a replacement 0.1 microfarad cap rated for across the AC line applications. And being a more modern style, it's smaller, leads aren't as long, and they're not axial, meaning they're not coming out of the ends of the caps, they're coming out of one side. So to go between the original points, I would have had to add some extension wires, or leave part of the original lead there and twist them over, make some J-hooks out of it, put some heat shrink tubing over it. Or, by studying the circuit a little bit, knowing what their intention was, and studying this terminal strip, I realized, oh, that lug is just riveted to the chassis. It's ground. Well, hey, so is this one on this terminal strip here. So instead of running the cap between these 2 points, I can go between these 2 points, which is no problem with these short leads. There's nothing over here at all. So there we go. So now when I work on this same chassis in the future, use this one as a reference, I can just take that cap, clip out the old one, stick the new one right in here, done. So, Now most of the others are much more straightforward. I can pretty much just blindly clip them out and put in the new parts. But I just thought I'd point that out. Something else worth noting, the other decoupling capacitor I'd mentioned, this guy, through that 1K resistor, it goes to lug L28U. That's for the audio output tube. So where the heck is that? Audio output tube is right here. This is lug L28U. Hey, that's that same area I was just talking about where I could stick down one cap. It turns out that both these lugs, L21U and L28U, that both have a 20 microfarad 300 volt cap, are right near each other. So actually both of those electrolytics could be located right in this same little area right here. I just pried the bottom off of this cabinet, and man, it's not just rusty. There is, well, I don't know if a critter was living in here or a capacitor lost its guts way back in the day. But whew, let me see if I got a tub big enough, and if I do, I'm just going to dunk this in some Evapo rust. I guess first though I should take a wire brush and go over that and get some of that crap off. Let's talk about the cabinet a little bit. The bottom safety screen had a really horrible spot of corrosion. Well, originally I was hoping it was mostly some type of critter droppings or capacitor or transformer guts, something like that. But no, it was actually bubbling up from corrosion. This is pretty thick steel too, so things got really bad to eat a hole right through it. I used this rather aggressive rust remover on it. This stuff, which is some type of acid, phosphoric acid, and I think hydrochloric acid. It is pretty aggressive at removing rust. One problem I found with it though is that you will immediately get flash corrosion if you don't immediately coat the metal with something. And in hindsight, if I had realized things were so bad it ate a hole through it, that wasn't from the acid I used. I mean, the rust was just that bad that the metal had lost its integrity. What I think I would have done if I had to do this over again is to use rust neutralizer and just leave it there. Rust neutralizer will convert the corrosion to like iron phosphate, I believe, which is stable. It'll inhibit further corrosion and kind of stabilize the corrosion that is there, and then you can paint over it, and I wouldn't have a hole here. Now, it's on the bottom, nobody's ever going to see it. This metal's pretty thick, so it didn't compromise the structural integrity or anything. Anyways, since I removed the rust, I did paint, or prime it and then paint it. It's a little bit lighter than I would have liked. I'll see if I got some dark brown spray paint, otherwise I'll just leave it. Otherwise, the cabinet is in pretty good shape, actually. Considering the dampness, the wood wasn't affected by it, nor was the top mesh screen. So there's no warping of the wood, no separation or anything like that, and no veneer coming off or anything, so that's cool. Another P-clip that bit the dust, now that I know what these are. Thanks, guys, for all the comments telling me what these things are called. I will be replacing that one. It was originally there. And most importantly, we have legs. I actually got these a while ago. If I hadn't, or I should say the legs were the tipping point in making me decide to go ahead with this restoration. Without the legs, I don't know that I would have bothered. So thank you to the fellow restorer that kindly provided these. I did leave them sit overnight in Evapo rust and used a brass wire brush to remove all the specks and bits, because this had pitting on it just like the arms on the Siesta I worked on. However, the legs do have these feet that are pushed on. Now, like as is often the case, these have worn through, so the metal's actually protruding. The reason that matters is if I want to heat this up and use the brass wire brush technique, it would melt the feet or catch them on fire. These are probably hard rubber. Certainly would smell horrible. But since these are completely worn through, I think I'm inclined to just bust them off. I have been on the hunt for replacements. I have another holiday set that could use some new feet as well. The legs attach like so. Now, I was wondering what happened to the original ones. Possibly they were damaged so bad they were removed. Seems a little unlikely. But another possibility is there was a stand for this. They're very uncommon. I've seen a couple on eBay over the years. And what it was is you could take the legs off, and the stand had a similar support, and you would like screw it into the cabinet. Stand being made out of similar looking metal, but it would get the setup to be like a mini console with wheels on the bottom. So it wasn't a stand the set would sit on top of. The set actually attached, like screwed into the stand. Regardless, we've got legs. So I have looked on, I think, Grainger for replacement feet. I found some push-on ones that were the right diameter. I think this is 1/4 inch or thereabouts, maybe a little bit smaller. But they're white, kind of white rubber tip things that are really not, right? Oh, this one's coming off already. So if any of you have suggestions where I can find spherical, hard rubber feet with a shaft diameter of, something a little less than 1/4 inch, 3/16 maybe. While rummaging around for parts, I came across a container I hadn't seen since we moved over 3 years ago, and that has new stuff. I think I got all this stuff from Grainger with the thought that I could, while rummaging around for parts, I came across a box I hadn't seen since we moved over 3 years ago, and that had parts from, I think, McMaster Car, new production parts that I thought I could use with Predictas. So one thing, these potentially I can use on legs. So they're not little hard rubber balls, but these are basically the right diameter, and they would work all right, and they would look all right. So at least for now, I'll go with those. I also have these guys, which I can use with 17-inch sets. Most of my 17-inch sets have 1 foot missing. They're all riveted on, so it's kind of annoying. I don't think these are exactly the same height, but if they are, potentially I could just drill out 1 rivet and put on 1 new foot and leave the other 3 on, or replace all 4 so they're matching. The originals are, I think, maybe, I don't know if they're plastic or hard rubber, but these are definitely plastic. What else we got? Oh, another type of foot that could potentially be used, but these are a bit beefier. I think I'd maybe use these in some other heavier table type sets. It's one thing annoying when you buy stuff online. You can't touch it, feel it. You just have to kind of go by measurements and hope it'll work out all right. This is hard rubber strapping that I potentially will use for CRT mounts that have rotted away. And these snap on to the arms, the end caps. CRT housing they are sometimes missing. The originals were steel that were brass plated. These are just steel. I couldn't get solid brass ones, although I do know that the guy who makes the Reproduction Networks does now sell solid brass ones. But I got a bunch of these as well. And I think this is, yeah, just more of those hard plastic feet. So one thing when you order from some of these suppliers, you got minimum orders, so I think I had to get 50 of those end caps and 50 of these feet, maybe 100 of them. But they don't cost much, so it's not that big a deal. But but I certainly have plenty of these to go around, more than all I probably ever need. Let's take a moment here and see how these rubber feet will fit on these legs. So you can see these are worn out. Start taking them off. It turns out these are actually screwed on. Underneath these bald feet, the metal shaft is actually threaded. These new ones aren't really, although they do have some ridges inside, but they aren't quite really threaded. I already tried this on the other one, so I know that they will fit with a little bit of persuasion. Now the only issue though is that they're at an angle, so when the set is sitting there, just this part's going to rest on it, whereas the originals, well, they were a bald foot, so just part of this ball would be resting on the surface as well, whereas on the back, the whole foot will rest. So, well, again, it's better than nothing. They certainly fit. I'd never taken these off before. I just assumed that they were pressure fit. It never occurred to me that the legs would be threaded. Also, I'm not quite sure how deep that goes, but it's going to run into this cross piece where it attaches to the cabinet. So I don't know if that's seated quite all the way down. But hey, you know, for now, whatever, we'll get the job done. Your feet. Until such time as I can find something more appropriate, which will do. Here's a quick look at the cabinet with the legs installed. Works just fine with the new feet installed. Do need to do some cleaning up on this housing, and the cabinet's got quite a few chips and dings, and it's a little warped. UHF tuner, I think I need to put a hole in somewhere around on the side. I'll have to figure that out exactly. I think it goes like here. I hope it's got enough clearance from the leg. I don't think the UHF model used different legs than the VHF. That would be kind of tragic. So I better measure that out and figure that out before I go and drill a hole in this thing. By the way, this is not some really nice veneer or anything. This is all faux finish. The only real wood is like this front trim piece here. This is metal. They painted to kind of look like wood. And this is all fake wood grain with cheap wood underneath. That's why it's flaking off all over. What one can do, and I probably will do, is take some brown paint pigments and try to kind of blend it in and then clear coat the whole thing to stabilize it. Certainly don't want to strip it down. You will be left with a very, very ugly looking cabinet. As is often the case, the original tapped sand-coated power resistor is bad. So what to replace it with? Well, you can get a tapped modern power resistor. In fact, I've been making them for many, many years with an adjustable slide tap. But you only get one tap. We need two. So the typical way people would do these is with discrete power resistors, so we're going to need three. But you got to get a little bit creative because your standard power resistor has a lead coming out of either end of a rather large body, so to get it to go to the terminal strip here, you need to loop around, but the leads aren't quite long enough. So what I've been doing is taking some bus hookup wire, which is, well, it's just uninsulated wire, tin coated, and I made a pigtail slid it on the end, and I'll put some heat shrink tubing over it. This one, the 8 ohm resistor doesn't need to be quite as high a wattage, so it is just able to make it over to the terminal strip, and I took this one and looped it over and put a little thing there. So there is a little bit that's not insulated right here, but there's nothing else in this area except some insulated wires down here in this wiring harness, so I'm not that concerned about it. In the past, I did find some resistors that are called cement resistors. Typically, they come in a molded body, and there's a wire wound resistor put inside, and they fill it in with, well, cement. I did find some that had leads coming out of both ends. Both leads coming out of the same end, and I did use those on 1 or 2 projects. The only thing I don't like about these is the leads themselves are a little flimsy. The only thing holding this up are the leads, and these can get a little bit heavy. So imagine something that's about 2-3 times the size hanging out into space with flimsy leads. It's going to flop around and sag down. These have really beefy leads. These are Dale power resistors rated for 10 watts. As far as what wattage to use, it's not that simple. Again, the schematic isn't the greatest, but at least we can get some sense here. So it's represented by these 3, 17, 13, and 8. Now this is all part of the filament string. It taps in starting at the 12DQ6 horizontal output tube. Wraps around through these 3 resistors, the thermistor, and then right to the AC line. However, we've got something in parallel with the 17 ohm. That is a pilot light for the VHF tuner. And although it's not shown on here, if you have the UHF option, there is also a lamp, I believe, in parallel with the 13 ohm. That's why they have the taps on here. If you didn't care about the pilot lights, use a single resistor, you're done. If you don't have the UHF option, I believe you could combine these two. Power rating is not quite so simple, though. If it wasn't for the lamps, it's 600 milliamps in the tube filament string. Power is current squared times resistance, so you can calculate those easily, and then you should double it or more for some overhead safety margin. But you've got a lamp in parallel here, 250 milliamps. So instead of 600 milliamps going through this resistor, it's actually 350, which cuts down the power rating on that considerably. However, what if the light burns out? Also, when you turn the set on, the lamp filament is going to be cold, so it'll have less resistance and actually be more. Most of the current will go through the lamp until it warms up, then it'll be 250. So if the lamp was always there, and it was always good, we could use a considerably smaller resistor, like half the wattage. But you don't want to do that because you don't want to rely on that lamp never burning out. So do worst case scenario and forget about the lamps. Assume there's 600 milliamps going through all of these. In which case you need to use, I know the number's right in front of me right now, but it's something like 5 watts, 10 watts, and 13 watts or so. And yes, I do realize I have a 10 watter in here, and it's also a 20 ohm, not a 17. Probably 18 to be the closest standard one you could find. However, that's what I have on hand. This is the one that's in parallel with that lamp. As long as the lamp doesn't burn out, I'll be well within safety margins. Even if it does, this won't burn out probably, but it'll get pretty toasty. So if I'm using the scenario as the lamp burns out, I should turn it off until this can get replaced. I will also order up a beefier one. Speaking of that, thermistor. The original was 400 ohms at room temperature and 11 ohms hot. These are 220 ohms at room temperature and they're rated for 1 amp. What does that mean? That means the max you should put through them is 1 amp. Now you might think, well, I'll get a 5 amp, I'll overrate it. No, that's not what you want to do with thermistors. You want them to be close to their limit because they work by getting hot. If you put a 5 or a 10 amp thermistor in there, it wouldn't get hot enough to decrease its temperature. That's what these do. Current goes through them, they get hot, their resistance goes down. Now these are great in some applications. Because they're so small, they heat up fairly quickly and their hot resistance is really low, like I think less than 1 ohm at operating temperature. I put 2 in series, which is fine. You could put as many as you needed, so that'll get me to 440 ohm at room temperature. However, when they're hot, it'll be more like 2 ohms, not 11. I can compensate that by adding more resistance to this string. But what I'd really like to do is they make another type that's bigger. So it'll take a little bit longer to heat up, and the on resistance, hot resistance, is higher. Something more like this. But again, I don't have any on hand, so these will do for now, especially because I can run this set off of Variac and dial down the line voltage to 117 or whatever. And I'll have to tack that on to another upcoming order. This is how my filament dropper ended up looking. I do have a more suitable resistor on the way for this guy, and some better thermistors on the way, ones that have a higher hot resistance. Today's Friday, they should be here on Monday. I can just easily undo this. But while doing this, I was looking at the SAM schematic, comparing it to the Philco service info, and I noticed something. Something doesn't match. Now, SAM's is laid out better. Sorry, I don't have it in front of me right now, but it's laid out better in terms of they show the filament string and the resistor dropper string, or so I thought. I noticed they're not the same. SAM shows the thermistor, then 13 ohms, then 17 ohms, and then 8 ohms. Philco shows thermistor 18 or 17 ohms, 13 ohms, and 8. In other words, they have these flipped. But they both show a number 44 bulb across this resistor. In the case of the SAMs, it's across 13 ohms. In the case of Philco, it's across 17 ohms. So, I did a little math. So, what were they trying to accomplish with all this? Why not just throw one big old resistor in there and call it done? There are pilot lights in this. See one right here. They need to power those. Your standard, super common, off-the-shelf pilot lights is number 47 and number 44. They both run on 6.3 volts. Number 47 is 0.15 amps. Number 44 has 0.25 amps. They typically are used in parallel with 6.3 volt filament tubes, which are very common. Well, this is a series strung set. If they wanted to put those in series with the vacuum tubes, perhaps they could have, but they would have needed bulbs that have 0.6 amps going through them, which would be pretty toasty bulbs if they're also 6.3 volts. That'd be 3.5 watt bulbs. Also, if they did that, if the bulb goes out, your TV dies. So they had two goals here. One, to use cheap, common bulbs, and two, not have the set die if the bulb goes out. How do you do that? Shunt resistors. So the brunt of the current goes through these resistors, but some goes through this as well. So if you do the math, you get 6.3 volts. You can divide that by the difference of 0.6 amps and 0.25 amps. You get 0.35 amps needs to go through this resistor. Do the math, you get 18 ohms. Why they went with 17 ohms, I couldn't say. Maybe because This big old resistor they used was an already available part on the market. They didn't want to have a custom one made. Similarly, if you go for the other bulb and do the math and subtract 0.15 amps from 0.6 amps, you get 0.45 amps into 6.3 volts, you get 14 ohms. They went with 13. I've got a 12.5 and a 20 in here right now. So the bulbs will be a little bit uneven. It won't really matter much to the overall current flow through all the vacuum tubes, but the bulbs won't be quite right. In the case here where I've got 20 ohms instead of 18, there'll be a little bit more current going through the bulb. In this case where I've got a little bit lower resistor value, then it should be 12.5 versus 14. There'll be more current going through the resistor. This bulb will be a little bit dimmer. Also means if you were thinking, hey, I'll throw in some LED long life bulbs like a 47 equivalent, you can certainly get them. They won't work right in this. You need the current to be going through here. So back to what my scenario of these bulbs burned out. The set will keep working, but it will be somewhat starved for current. In particular, like this will cut it down because there should be almost half the current going through this bulb. This bulb goes out. The set will somewhat equalize because if the tubes cool off a little bit, the resistance in their filaments actually drops, which allows more current to flow. So it's not quite so simple because all the tubes are in essence thermistors, but they're the type where the colder they are, the less resistance they have. Whereas with this, the colder it is, the more resistance it has. So all this stuff kind of somewhat self-regulates a little bit, but that is why this is the way it is. And this bulb in particular is only there for the UHF tuner. I think that's what I went with 0.15 amp, so if this is not even present, it doesn't have as big an impact as if this one was not present. Alright, all that being said, I'm really anxious to see these lit up because I believe the way this works is when you're on VHF channels 2 through 13, I think the UHF bulb is off and the VHF bulb is on, and I think when you're in the UHF position they're both on or something to that effect. So I don't think they ever want to cut the VHF bulb out because so much current goes through it under normal operation. At first I thought maybe when you're in UHF on the VHF bulb goes out and the UHF bulb goes on, but I don't think they'd want to be messing around that much with the current flow. Alright, so that for now is done. Moving on to the rest, I'm starting to replace some of the other caps. There is one of those couplate network thingies down in here. The TV Restorer kit did include one, so I will be replacing that guy. And I'll slowly be working my way through this. Oh, something else I wanted to mention. One of the stakes off of this board went over this way, and there was a capacitor going from this lug over to this pin on this tube. This is 12DQ6 output tube. Before I replace it, I wanted to verify what cap it was and that I was using the right value and all that. And I realized there's no internal connection on that pin to this tube. They were using that for a tie point. There's also a wire going to that. So that cap was simply going to ground into that pin and a wire onto the board. Now that seemed odd. Why would they run a wire off of the board, have one of those wire wrap stakes and all that, just to go to a single capacitor, nothing else? However, I saw something similar in this Siesta set. And sure enough, I looked on the schematic. Yeah, that's L14U. It goes to nothing other than a 0.1 microfarad 200 volt cap. And then off to some stuff. Why didn't they put that cap on the board? There's certainly plenty of others. Maybe they ran out of room? I don't know. I mean, this is where that stake is, this guy. So yeah, there really isn't room down here to put a 0.1 microfarad cap. That'd be a little on the large side as far as old style caps go. So what did I do? Took the cap out, took the wire out, stuck it on the board. Because right next to that is this, which is ground. So I just bridged the two, and that's that. And there will be nothing connected to that point. And again, with that philosophy of put the parts near where they're being used, lower the impedance of the circuit, eliminate some wiring, eliminate some source of noise pickup. Now, as far as grounding goes, something when I'd asked about what was missing from this board, which again was this coil, a number of you mentioned about these stakes. You thought maybe they were broken off or something didn't look right. Well, all these grounding points, it's just the same as the wire wrap stakes. They're just bent over. And there are corresponding kind of fork-looking things. Pardon me if you find that gesture offensive, but there are things like this sticking up from the chassis, and then these just get bent over and soldered down into them. Maybe we can see, yeah, here's one of them over here. And really they are just part of the chassis. When this thing is all stamped out, they just bust these out and fold them over like origami. So it's all one piece of steel. Oh, and speaking of that, I noticed this corner of the chassis got a bit bent in. I kind of straightened it out a little. And while doing so, I noticed something odd too. There is a square cutout here. This had been in there. And you can still see there's one over here on this side. Normally holiday chassis don't have those. See, this doesn't have them. I think those are used in the pedestal model. I only worked on one. I know it's the same 93L7 chassis. Or sorry, 9L37 chassis. The pedestal is the one where it's also called the barber pole. It's vertical, and then the swivel screen is on top of the chassis. And that set, instead of being horizontal, was vertical. So you would need mounting points like this because the chassis would be like this. But I don't think this came out of a pedestal set, because in the pedestal set, the tuner also has to be rotated, I believe. I don't know. Like I said, I've only worked on one, and well, regardless, I don't need these. But everything else seems to match up, comparing it to the other reference chassis over there. Alright, anyways. So, it seems like no matter how careful I am when I place orders for parts, I'm always missing something, or I don't anticipate everything I'll need for the next project, in spite of all these parts, and this is just a fraction of all I've got. I keep running out of things, or I don't have the things I need, so hence I'm just tacking stuff in. But I think I can keep forging ahead over the next couple days until that order gets here, and perhaps do enough. I'm pretty sure I've got all these key components, because I'm kind of anxious to try powering this set up. Especially because I know the picture that came with it tests okay, but I also, way down there in the corner, you may recall I scavenged, get another 93L7 chassis and CRT out of somebody who parted a Predicta set out not far from where I live. But that picture tube tested weird. It had great emission and cutoff, but it had a purple glow in the neck, which usually means air is leaked inside. So I'm really curious to see, can I get an image on that? I don't think it's got a slow air leak. I think it's kind of in the gray area of it still kind of works, but it's going to slowly die. So we may get some interesting images on it. Alright, I'll shut up for now and get back to wiring all this stuff up.